Hello students, so from today we are going to start unit 6. The unit 6 is yours solution of ordinary differential equations. In this unit we are going to solve the differential equation. Now what is the differential equation? That is, if I am writing dy by dx equals to some function in two variables x and y, this will be your ordinary differential equation. That is, dy by dx equals to a function of in two variables x and y. So we are here in this particular unit are going to solve this type of ordinary differential equations of order 1. This is called as ordinary differential equation of order 1. So in this particular unit we are going to solve this type of equations by the help of these four mentioned methods. The number 1 is Euler method, the number 2 is Euler modified method, number 3 Runge-Kutta method of order 2. Order 2 is in your syllabus, order 4 is not included in your syllabus, and number 4 Picard's method. So today we are going to study the first one, that is Euler method. And basically in Euler method there are two things required for examination. That is, number 1 the theory portion, that is how the formula is derived. That questions comes multiple times, that prove the Euler method. And number 2 is we know the problems regarding this method. So here we are going to learn two things. Number 1 the theory part, and the second one the numerical part. So first of all, let us start with the theory part of this Euler method, that is how the formula is all derived. Okay, so Euler method. Basically here in Euler method we have to solve this differential equation. So first of all we will write in this way. Let us consider a first order differential equation as we have considered this dy by dx equals to f of xy. With this is there is a condition. Always remember that whenever you are going to solve a particular differential equation, you are be provided with a condition, and that condition is called as your initial condition. That means this particular condition is called as your initial condition. Now let us see what is the initial condition. The initial condition says that y at the point x naught equals to y naught. That means y at the point x naught gives the value y naught. Remember, this is a notation. Y at the point x naught is your y naught. So this differential equation, we have to solve this differential equation with the help of this initial condition. Now what we have to find at the end, we have to find the approximate numerical value of whom? We have to find the approximate numerical value of the y at a point xn, which is denoted by yn. That means we have to find the value of y at the point xn, which is denoted by y of n. So this is a notation. We can treat this as a notation. That is, finding the y at the point xn is denoted by as y suffix n. This thing we have to find. So before that, first of all, we have to assume some things. So you have to write like this. We divide the range, that means we will divide this interval x0 to xn into n equal partial intervals. That means we are going to divide, suppose this is your interval x0 to xn. Now we will divide this interval, that means this particular range, into n equal partial intervals like that. x0 x1, this is one interval, then another point x2, this is another interval. Then similarly we will divide, suppose here xr minus 1 point, and here xr. So in this, so by the help of the point x0 x1 x2 xr minus 1 xr, and so many points are there, by the help of that some points we are going to divide this range x0 to xn, this range, into n equal partial intervals. So that the thing here written, we divide the range x0 to xn into n equal partial intervals by the point x0 comma x1 comma x2 dot xr minus 1 comma xr plus 1 dot xn. By the help of these particular points, we are going to divide this range into n equal intervals. Okay, now the most important thing, this relation is used multiple times. What this says, xr equals to xr minus 1 plus h, where r varies from 0 1 2. That means this relation defined as, if suppose I am putting the value of r equals to 1, it means putting r equals to 1, it gives x1 1 minus 1 0 x0 plus h. If I am going to put xr equals to 2, then x2 is, we are putting r equals to 2, there's 2 here, 2 minus 1 1 plus h. If we put r equals to 3, so x2 plus h. So this is the formula. With this formula you will use multiple times in this Euler method, and this particular h, as you all know, you have done this is called as a step length. That is a difference between 2 points. Suppose there are 2 points x0 x1, the distance, this distance is called your h. This distance is called your h, that is the step length, and the step length is fixed here. Okay, so this is the theory. You have to write the theory in this way only. When it comes in exam, if the question comes like that, derive Euler's method formula, then you have to write in this way. Okay, now after that, what we write, after that you will write, assuming, this line is important, assuming f of x comma y equals to f of xr minus 1 comma yr minus 1 in this interval, that is xr minus 1 to xr. You have to remember this, assuming f of xy equals to f of xr minus 1 comma yr minus 1 in this range, and then integrating 1. What is your 1? That is the main equation. dy by dx equals to f of xy, integrating in this range, in the range xr minus 1 comma xr, we gets the Euler iteration formula. That means now we have to integrate this thing and in this particular range. Okay, so I will just show the how to integrate this in the particular this range, and up to this you have to write in this same way. So you will write in this particular form. Now first of all, some rough work. What was dy, first equation number 1, dy by dx equals to f of xy, this is given to you. So what we can write, dy equals to f of xy into dx. We can transform this dx to that side. Okay, we can transform this dx to that side. So now we will integrate this thing. So after that part you have to write like that, integration dy, and that side integration f of xy dx. And what was the range? Range was xr minus 1 xr minus 1 xr. Okay, now remember one thing, integration over dx is x, and if the limit is there, suppose the limit is from a to b, we will write, we all know that a to b. Now putting the upper limit in place of x, put the upper limit, what is here, b, minus putting the lower limit in place of x, that is a. So the integration formula of here is a to b, dx is b minus a. One thing you have to remember, integration over dx is x, the number 1. Number 2, you have to remember, whenever you are integrating, limiting the integration, that is definite integral, this integration value is x, upper limit is here, this called the upper limit, this called the lower limit. So now first of all put the upper limit. What is the upper limit here? In place of x, just put b minus the lower limit a. Okay, so just simply you will use here. See, just I am showing the proof, how the proof is done. This is not mandatory, you also have to show this proof only. You can directly write the formula. just after that line, last line, that we get the Euler iteration formula as, you can directly write the formula after that. This is just how the formula is derived. I'm just showing that. It is not mandatory you also have to show this formula proved in your exam. You can skip this proving part. Okay, so now integration of dy is y from the range, what was the upper limit here, xr, here xr minus 1. Now we have assumed f of xy, if you remember we have assumed f of xy as f of xr minus 1 comma yr minus 1. We will use that here. If you assume this is a value, so that means this f of xy will come after the integration, as this is a value at particular point, so this function is become a number, that is a constant, so it will comes out of the integration. Now integrating over xr minus 1 xr dx. Okay, so now just putting now upper limit, that means y of xr minus lower limit y of xr minus 1. Okay, upper limit y, putting the upper limit, that means putting the value of y at the point xr minus y of xr minus 1. Here f of xr minus 1 yr minus 1, integration over dx is x xr minus 1 xr. So now y of xr is, we can write as yr, because earlier also have say y of xn can be written as yn. So similarly y of xr we will write as yr. Y of xr minus 1 will be written as r minus 1. Now here putting the upper limit, in place of x put xr minus xr minus 1. If you remember, I have said xr equals to, at the starting of the proof, xr minus 1 plus h. So that means xr minus 1 equals to h. That is xr minus 1 equals to h. So we can use this value here. So yr not minus yr minus 1. Instead of this we can write h f of xr minus 1 minus yr minus 1. So that is yr, taking this minus side term to that side, got the proof. So finally, in general, if you generalize this formula, that means if you replace r by n, we will get yn equals to yn minus 1 plus h into f of xn minus 1. Just in place of r I am replacing by n, yn minus 1. This is your Euler formula. Now basically what you can do, after writing that line, we get Euler iteration formula as, you can directly come to this line. You can directly write this. There is no required to show this calculation. It is, I am just showing the calculation for your explanation how the formula is derived. You are not mandatory to show this proving part. You can directly write this formula. Okay, so don't get so stressed regarding the proof. This proof is for those who are willing to write the proof during the exam. There is not a mandatory that everyone should have to write this proof part. You can directly write the formula. So what is the formula? Yn equals to yn minus 1 plus h into f of xn minus 1 comma yn minus 1. Just remember this formula. By using this particular formula, we will solve the numericals. So this is about the theory part, about the formula part. Okay, so now let us solve some few questions by using this formula. Okay, so the question is, find y of 0.15. We have to find y of 0.15 by Euler's method from the equation dy by dx equals to x square plus y square, where y of 0 equals to 0, correct up to 4 decimal places, taking step length equals to h 0.05. Now what are the informations I have? So first of all, what is given here? Dy by dx equals to x square plus y square with y of 0 equals to 0. Now if you compare this line with the first line of the proof of the theorem, what was the line? Dy by dx equals to f of xy. And what is here? X square plus y square. So here, what is your f of xy? Always remember that your f of xy is nothing but the right hand side, x square plus y square. Okay. Next, what was there in the theorem part? Y of x0 equals to y0. So that means what is the x0 here? X0 is here 0. And what was the y0? X0 is 0. And what was the y0? Is also 0. Because if you compare y of x0 equals to y0 given in the theorem part. So here what is your x0? If you compare, this is your x0 point. So this is 0 and y0 is also 0. And at the last line, the step length is given to you h 0.05. Step length means by this particular step it will be proceed. That means the first step is 0. See, not means initial. That is the first step. The first step is 0. The next step will be how much difference? 0.05. See, this is initial step. That is 0 step is your 0. Then the next step 1 will increase by which length? 0.05. So this length will be 0 plus 0.5. The next step, there is step 2. That will again how by increase by the factor 0.05. That is 0.05 plus 0.05, that is 0.10. Third step, that means again what is the length? 0.05. So 0.10 plus 0.05 is 0.15. We have to find this thing. That means we have to go up to this thing. The step length means from one step to another step, the difference between that. So now basically it's very simple. Just by using the formula we have to solve this. Okay. So first of all, y0 we get. Y0 we get. Now let us to find. Now first of all, x0 is our 0. So what will be your x1? By the formula, x1 equals to x0 plus h. x0 is 0, h is 0.5. So x1 is 0.05. This is your x1. Okay. In respect of this x1, what we have to find our y1. Very simple. In respect of this x1, we have to find our y1. So you can remain this as first step. You can mark this as also first step. Okay. So now we have to find our y1 because we know our y0 is 0. Next, but we have to find y1. So y1 can be nothing but this is your y of x1. We know that this notation is very familiar. Y of xn equals to yn. Here n is putting 1. Okay. What is the x1 value? 0.05. Okay. See what we have to find in the question. Just remember y of 0.15, 0.15. What we are finding here? Y of 0.05. Now using the formula, what was the formula? Yn equals to yn minus 1 plus h into f of xn minus 1 comma yn minus 1. This was the formula. Okay. What we are finding here? Just remember what we are finding here. y1. We are finding here y1. That means in place of n, what we are going to put? 1. We are finding 1. That means in place of n, what we are going to put? 1. So y0 h f of x0 comma y0. Okay, what is y0 value? 0 plus h. x0 value 0, y0 value 0. So 0, h value, what we know? 0.05 into, okay, now what is f of xy given to you? X square plus y square. So what will be your f of xy is x square plus y square. So f of 0 comma 0, that means in place of x, the first one stand for x. So x is 0, second one is 0. So putting here, that is in place of x, what we are going to put? 0 square. In place of y, what we are going to put? 0 square. So 0 square plus 0 square, finally 0. So finally what we get? y1 equals to 0. What was your y1? We know that y1 is nothing but our y of x1, and y of x1 means our nothing but y of 0.05. So what we get as 0. So what we get here? y1 as 0. So from the first step, y1 0 and x1 0.05. Okay, so we have find here y of 0.05. Next, what we have to find? Next step, x2. Okay, second step, x2 equals to x1 plus h. Now what was your x1? 0.05. What is your h? 0.05. Now adding this 2, we get 0.10. This is our x2. And respective of that, we have to find our y2. That means what we have to find in this respect, we have to find our y2. y2 means y of x2, right? And what is y of x2? What is the x2 value? 0.10. So here we will find this thing. What will we find? Y of 0.10. Okay, so let's start. Again the same formula. What we have to find here? y2, that means putting n equals to 2. That is y1 plus h into f of x1. We are just putting n equals to 2. Remember that, because we are finding y2, comma, putting n equals to 2, that is 2 minus 1, 1, y1. Okay, so now from the previous step, that is step number 1, what was the y1 value? 0. H value 0.05. f of x1 value from the previous step, x1 value 0.05 into y1 value 0. Now 0, so 0 means, that means we have no need to write this term. Now here 0.05. Now f of 0.05 comma 0. F of xy is given such, remember this, f of x comma y given to you. That is, what is the x here? 0.05. Put it here. That is 0.05 whole square plus, putting in this function, just putting in this function. What is the x here? 0.05. What is the y here? 0. That means 0 square. So after simplifying, we will get here, after multiplying and simplify, we will simply get here 0.00012. The question demands for 4 correct decimal places. If you make it 4 decimal places, so it will approximately becomes 0.0001. So this is your y2. So finally, what is your y2? 0.0001. So we got our y2, we got our x2. So next, see, here we have find y of 0.10. Still, what was the question demand? Y of 0.15. So you can guess that in the third step we are going to find the answer. Okay, so now third step. That is x3 equals to x2 plus h. What was their x2? 0.10. What was your h? 0.05. So finally x3 we get 0.15. So using this x3, we have to find here y3. We have to find here y3. y3 means y of x3, and what is x3? Y of 0.15. So we have to find here y of 0.15, and that is the question's demand. So finally we have to find y3. That means putting n equals to 3. So putting n equals to 3, we will get y3 y2 plus h into f of x2 comma y2. Now what was your y2 value? 0.0001 plus, but we will put, see, remember one thing, when we are approximating, we can approximate the final result, but while putting the values, you make sure you always put the total value what we get. So we get the y2 value as 0.0012. Not we are writing the approximate value, I'm just writing the full value, plus h is your 0.5, f of x2 was 0.10, and y2 is 0.00012. Okay, so after that 0.00012 plus 0.05. now this function f of 0.10 and 0.0012. now what is x here? 0.10. that means putting here 0.10 whole square plus, now what was the y? Y is y square. What is here? 0.00012 whole square. Now if you simplify this, after simplifying you will get 0.00063, and if you make it as a 4 decimal, you will get 0.0006. so finally y3 is 0.0006. y3 means nothing but your, so this is your required answer. So in this way, by using the Euler's formula, that means this particular formula, we are going to find the value. Thus you have to analyze up to which step we have to go by just seeing the question, because you know your step length and you know what you have to find, as well as you know from which point you are going to start. You have to start from the initial point, you know your step length, so you can easily guess up to which point you have to proceed. Okay, because 0.053 times gives 0.15, so that's why we have proceed up to y3 3 times. So now let us try one more example. This one the simplest one. We will go for another some lengthy questions. So now let us proceed to the next question. Now here in this question, given dy by dx equals to y minus x by y plus x. Okay, so first of all let us write what are given to you. That is dy by dx equals to y minus x by y plus x. With the initial condition, okay, with the initial condition, that is y of 0 equals to 1. Okay, we have to find y of 0.1 by Euler's method, correct up to 4 decimal places taking step length. Now what is the step length? 0.02. That means by this step we will proceed. Okay, so now what the information we got from this particular line here, first of all your f of xy, the very important, what is f of xy? This is the right hand side function, is always your f of xy, that is y minus x by y plus x. And x naught, just remember that with the initial condition x naught is your this bracket number. So x naught is, what is the then bracket? 0. So x naught is your 0 and y naught is your right hand side. Okay, because in the theorem part only we have written y of x naught equals to y naught. So if you compare this expression with this expression, that x naught is your 0 and y naught is your 1. Okay, and h is given to you 0.02. Now first step, that means we have to find here x1. x1 means x naught plus h. Okay, So x naught is your 0, h is 0.02, that is x1 is 0.02. So here we are going to find our y1. y1 means y of x1, y of x1 means y of 0.02. So after that, what is the formula? Yn equals to yn minus 1 plus h into f of xn minus 1 comma yn minus 1. Very clear. Now we have to find here y1. We have to find here y1. y1 means y of x1 and x1 means y of 0.02. So y1 means, just I am writing this line for making you understand that what we are finding basically, because the question demands to find y of 0.1. So up to which step we have to proceed. Okay. So putting n equals to 1, y1. Now n equals to 1 means this will become y naught plus h f of x naught comma y naught. Now what is the y naught value? 1 plus h value is 0.02, f of x naught value is 0 and y naught value is 1. So there is 1 plus 0.02. Now f of xy, what is the function given to you? Very careful. What is the function given to you? Y minus x by y plus x. Okay, now here f of 0 comma 1. So 0 means your x, y, 1 means here your y. So putting here 0 means your x, 1 means your y. So putting here 1 minus 0, y is 1, x is 0 by 1 plus 0. So after simplifying you will get 1.02. If you done the simplification you will get this one. So we have to make for 4 decimal places. So we can write it as 1.0200, 4 decimal places. This is our y1 and this is our x1. Okay. So now step 2. Okay, so second step, that means we have to find here x2. x2 means x1 plus h. x1 we have get 0.02, h is 0.02. So finally x2 is our 0.4. This is our x2. So here we have to find, with respect of x2 we have to find y2. y2 means y of x2 and x2 is your y of 0.04. Still we have to find y of 0.1. So we have to proceed further also. So for that we require the y2 value. So putting n equals to 2, we get here y1 h into f of x1 comma y1. y1 value was 1.0200 plus h. What was the h value? 0.02. f of x1 value 0.02, y1 value 1.0200. So now we have to put the values, that is 1.0200 plus 0.02. Now putting the values, now what 0.02 is the x here and 1.0200 is the y here. So putting the values, y minus x, that means 1.0200 minus 0.02 y minus x by y plus x. So if you simplify this, and first of all if you divide here, then multiply, then add, after doing all this you will get your y2 as 1.0392. Okay, so this is your y2. So now next step 3. Okay, step 3, x3 equals to x2 plus h. So x2 what we get? 0.04 and h as 0.02. So by that x3 we get 0.06. Now we have to find y3 at the point x3. That is, we have to find y3, which is our y of x3, and x3 means y of 0.06. So in the third step we are going to find y of 0.06. But what is the question demand? Y of 0.1. Still not reached. So we have to proceed further. For that we need the value of y3. So now y3, I've just calculated the part. It's as similar, so I've just done it's earlier only. So putting n equals to 3, so y3 equals to y2 plus h f of x2 comma y2. Now y2, from the second step we get the value 1.0392 plus h value 0.02, f of x2 value 0.04, and y2 again 1.0392. Now see, this is our f, 0.04 is the x here, and 1.0392 is the y here. So now again putting in this y minus x, that means 1.0392 minus 0.04 by y plus x. Now after simplifying we get as y3 as 1.0577. So this is all about the third step. Okay, so now we'll proceed for the fourth step. So fourth step, that is x4 equals to x3 plus h. x3 was 0.06, h was 0.02, so that means 0.028. So at the point x4 we have to find our y4. So y4 is your y of x4 and x4 is your y of 0.08. So in the fourth step we are going to find y of 0.08, but this is our 0.10, so we have to proceed next step also. So let us find the value of y4. So I've just calculated the y4, you just check it once. In the same way, just using the previous step results, we have find the y4. Okay, so now the next step, that means we have to go for the step number 5, because still we are finding our y of 0.08, but what we required, y of 0.1. Okay, so fifth step is x5 equals to x4 plus h. x4 was 0.08 plus 0.02 is 0.10, or 0.10 can be written as, we know, 0.1. So finally y5 equals to y of x5, and x5 is your 0.1. So in this step we are going to find y of 0.1, which is the required. What we have to find is y of 0.1. So in the fifth step we are finding our y of 0.1. So this is the last step. So here we are going to find y5. So y5, that is y4 plus h f of x4 comma y4 from the previous step result, using the previous step results and just putting and simplifying, we get our y5 as 1.0928. Just by using the previous step result and putting here and simplifying, we get our y5 as 1.0928. So finally in this step, y5 means your y of 0.1 equals to 1.0928. So in this way we have used the Euler's theorem and find the value. So the two things are most important, that is first of all your function, and the second thing is that you have to analyze at which particular step you will get your answer. That's by seeing the step length. Step length is very crucial, and the point at which you have to find the given y. You have to find the y, not the given y. You have to find the y at which particular point. So from by seeing the step length and at the point where you have to find the y, you can judge that up to which step you have to proceed. Okay, so this is all about for the Euler's method. There are some more questions. We will try to solve some more questions. Till then, try to understand and learn. I say try to understand as well as learn the theorem part, because theorem part comes in your exam, and for numerical we will practice some more questions. So if you have any doubt, any question, you can ask me. So thank you for watching this video. Thank you so much. Goodbye.